Yeah, what's up internet? Sinus Media here, and today we are going to go back to Sonic Pi. Haven't been in Sonic Pi for a while. A couple of years ago I did a video on making trap beats in Sonic Pi, which actually quite a few people have come and had a look at, which was gratifying, but the audio was terrible. I'm sorry about that. I'm just wondering if I'm going to redo some of that again so that people can actually get the ideas without having to listen to that poor quality. But in the meantime, we're going to come back and do some slightly shorter, more focused videos on different things. And this time I'm going to talk a little bit about more music theory stuff. And as the saying goes, if you know nothing about music theory like me, this is perfect for you. I've got a program here that generates chords and sends them off to FL Studio. So what I'm going to do is I'm going to talk about what this does, why it does what it does, how it does it, and hopefully you will I was about to say hopefully you will learn something, and that sounds incredibly patronizing, doesn't it? Hopefully it will be informative. But before we get to anything else, I just want to give a shout out to Hypernova Heathen, who dropped this big bite beat on my channel comments the other day. Here's how it sounds. It actually evolves quite a bit, this one. So yeah, it's a cool one, and it's there on the comments of that blathering idiot video I made recently. Does it work in Edison? Hell no, it doesn't work in Edison. It's too much sophisticated JavaScript. Try and run it, get an error. Have a look at the script. I tried to kind of just tweak it a bit, but there's too much. This charcode app isn't going to be translatable. Math, I don't think, is there. So sorry about that. Anyone that manages to translate it, good luck. But we're moving away from byte beats now. We're going to go back to Sonic Pi, a bit more sort of straight musical theory. I never really got into music theory. I've never really got my head around it. That's partly because I'm kind of lazy and stupid, and I find it confusing, and partly just because I find it a little bit illogical. I mean, there's too much arbitrary stuff. There's something very contingent about a lot of the way we think about it, and I've never liked that. I've never felt inclined to try and learn it all, because everything's just named weirdly. So I'm a programmer, and this channel, it's all about programming and music, or at least one of the kind of aspects of it is going to be about how we can use coding in our music. And Sonic Pi is a live coding language. I've got another whole love-hate relationship with live coding that maybe I'll talk about in another video. If I go into that ranting about that now, that will derail this video. And I want to say Sonic Pi itself is really cool. Big shout out to Sam Aaron who made it. Awesome. And that's why I want to use it. But another day I'm going to talk about live coding. So, time for a quick coffee break. I have just tweaked the code slightly, both the code I'm now going to explain to you and the code that we're going to talk about up here in a second. And so if you were paying very close attention to the screen earlier, you might notice a couple of changes, but nothing has substantially changed. So we're discussing this live loop here. If you remember, in Sonic Pi, a live loop is a separate thread, so this will keep on looping regardless of what else is going on in the program. And it's a very simple loop, this. What we're doing here is at the beginning of the loop, each time, we are calling this function called chord-seek, the function that we will explain in a minute, and that generates a sequence of chords for us. We give it 3 parameters: the root of our, or the key that we're in. I've got C4 at the moment. Is it a major or a minor? And then a series of chords which we just note as the 1, 6, 4 and 5. So one of the reasons it works like this is because although people talk about the 1, 6, 4 and 5, the musicians who learn to play them have to learn to remember what these keys are within the context of, say, C major or whatever key you're in. So this is going to hide that little bit of complexity from us. We can just think about our music as a series of the chords as understood through their numbering, like this, and I'll show you how that works, and I will show you how it's implemented. Having generated our chord sequence, we then just do a CS each. In other words, we iterate through that. Each time through the loop, the next chord in the sequence is attributed to the variable XS. In fact, XS, what we return is not just, or what we have here in our chord sequence is a tuple of 3 items: the tonic, the mode, and the chord itself. So the tonic is, again, it's just giving back to us what we gave it there, the C4. The mode is just whether it's major or minor again, and then the C is the chord itself. Why do we have that as part of the items within the sequence? Well, because we might be using the sequence in a context that isn't immediately after creating it, so we don't know what they are in our current scope. So it's useful to have them back again. But this is just a convenience again. It might be as well that a more complex version of this could even, say, change key at some point, and then the tonic would be different at that point. And we could use this information, say, for generating extra notes from a scale. But what's really important is this variable C, which now contains the chord itself. So remember, the chords we've asked for are the 1, 6, 4 and 5. They have now been calculated. In a minute I will explain what that really means. But the chord itself is itself just another array of individual notes, and so here we have a second loop where we run through each of those. Each time through that loop we attribute the chord. The note CN is just holding the note name, the note value. There is a built-in Sonic Pi function called MIDI note on that sends the MIDI note on somewhere else. Obviously the note we're sending is CN. We're sending it with a velocity of 50, which is just under half sort of maximum velocity, and we're sending it to a port called loop B internal MIDI 1. I have this program called loop B installed on my machine. I will put a link to it in the description. It's a very useful Windows program that lets us send MIDI from one application to another, which is what we're doing here. We're taking the MIDI from Sonic Pi and we're going to send it to FL Studio. If you look at our preferences here in the inputs, the MIDI ports, you'll see that here, I apologize, this is in Portuguese, but my computer is Brazilian. The outputs here are 2 options: the Microsoft wavetable, which is just the standard Windows one, and the loop B. We only want to send to the loop B. We don't want to also have everything repeated on the built-in one. So we just restrain that or constrain that by putting this port argument here. So having sent the note on, I'm going to shrink that again. We sleep 1.5. We're in 96 BPM, so it's not exactly 1.5 seconds, but you can think of it conceptually like that. Then we just send the equivalent note off, because if you remember, MIDI has got a note on and a note off as separate events. Sleep for 0.5. So the whole thing is 2 seconds, holding down the key for, or the keys for 1.5. So let's run that. and this is the most classic chord sequence in pop music, or one of the most. 1, 6, 4, 5. The 1 is called the tonic, the 5 is the dominant, which always kind of comes back to the tonic. You have to remember to stop it here, and then often it's useful to turn the sound off there. So I'm now going to explain enough of the theory for our purposes today. So here is I'm just using FL keys, here is our piano keyboard, and we can play the notes just like this. You'll see they light up. So we are in the key of C. This is the C here, and the scale of C is just the white notes going up from there. C, D. So C, D, E, F, G, A, B, up to C again. That's the octave. So that's notionally the same note. This note, they're the same note. They're an octave apart. We call each of these steps along the way the degree. So this is the root, or the tonic is our degree 1. This is degree 2, degree 3, 4, 5, 6, 7. The scale of C contains all the white notes. The degrees are 1 is the C, 2 is the D, 3 is the E, etc. And for each degree we have a chord that starts on that degree. Now, the simple chords are what we call the triads because they contain 3 notes, and they come from taking the first note, missing 1 within the scale, having the third one, missing the fourth, having the fifth. So the triad is like that. That's a major triad. It's a C major chord, and it's the first degree chord in the scale of C major. Right, the next one, starting on the second degree, D, is a D chord. However, and this is the thing that can catch you out if you're not familiar with this, this is not a major chord, this is actually a minor chord. Even though we're in the key of C major, we can have a D minor chord as one of the chords within that scale, within that key signature, and that is the second degree. The third degree starts on the E, the fourth degree starts on the F, the fifth degree starts on the G, that's the dominant. The sixth degree is there, starting on the A, and the seventh degree is there. So right, so those are the chords within C major, and they are the chords on the degree 1, 2, 3, 4, 5, 6, 7. So if we look at our code again, very roughly, that is what this sequence of numbers is picking out. The first degree, the sixth degree, the fourth degree, the fifth, or the dominant. So it's picking out 1, 6, 4, 5, 1, 6, 4, 5, etc. That's really all this function chord seeker is doing. However, it's got to do the right calculation. So a major triad, a major chord, is like this. And because we're in the C major, that's our scale is all on the white note. So the first, third, and the fifth. A C minor chord is like this. So the third is flattened, or it's one semitone down. So you can think of a major chord as when you start on the first, you go up 1, 2, 3, 4, and then to the next one, you go up 5, 6, 7. So in fact, it's a 4 and then 3. So if you go up from the first by 4 semitones and then by 3 semitones, you've got a major chord. If you go up by 3 semitones and then 4 semitones, you've got a minor chord. And the fifth, the third note in the chord, which is called the fifth because it's the 5th degree of our scale, is the same whether we're in major or minor. So this is a major sound, this is a minor sound. Now, when we come and look at within the key of C major, when we come and look at the D chord, the 2nd degree chord, you'll see that actually that follows the pattern of going up just by 1, 2, 3, and then 1, 2, 3, 4. So the 2nd degree chord in the scale, in the key of C major, is nevertheless a minor chord. Okay, when it comes to the 3 chord, again, we're just going up 3 and then 4, so that's also a minor chord. When you come to the 4 chord, though, you're going up 4 again and then 3, so it's back to being a major chord. So the calculation you have to make, now this works wherever you're starting. If we were in the key of G, for example, then the first chord, the tonic chord, would be like that, and that would be a G major. Then the second chord, the secondary chord, would be a minor chord again, etc. in G major. So that calculation, that's the calculation you have to do to work out which notes are the notes you're going to use for each chord of each degree within that key. And that is what this chord sequence, so if you're a real musician, if you're a guitarist or a piano player or any real musician, you have to work this out in your head. You have to, someone says, we're playing a 1, 6, 4, 5 chord sequence, then in the key of D, then you've got to D major, you've got to be able to figure out what those chords are. Let's just hear it for a second in minor as well, because again, the minor scale is different. The minor scale goes like this. So that minor scale has different notes in it, and now the chords are going to be like that for the first, they're going to be like that for the second, but well, let's see. I do know that this works, so let's see what the minor chords are like now. The same degrees, starting on the tonic, or the tonic chord starting on the root. So this is the 1, this is our 6th note, this is our 4th note, this is our 5th note again. But you'll see, in fact, because we're using this B flat here instead of the B natural, when it comes to building our dominant chord starting at the G, we've got to use the B flat, not the B, as our So that's what we're doing. We have written some code that will let us go from giving this information plus this series of the chords to it generating the appropriate notes and then sending that via MIDI. Let's just really make this very clear. C major, let's look at all 7 chords in C major. And let's look at them in C minor. Now, a kind of strange thing is you can see that we use very different notes for C minor, but there is a key which has exactly the same all white notes that C major uses, but is a minor key, and that is the A minor key. So the A minor is all white notes again. It keeps the same relationships, the same intervals of a minor scale, and we can see the chords that we would build there. Of course, it starts on the A, and maybe actually it goes too high. Let's start it on an A3 rather than A4. So those are our basic triad chords, but we can have more sophisticated chords or more richer sounding chords that have more colour, harmonics, however you want to think of it, by adding extra notes to the chords. So the most common way of extending our chords is to have sevenths. So what's a seventh? Well, if you remember here, we've got 1, 2, 3, 4, 5, 6, 7, and our chord is made of 1, 2, 3, 4, 5. But if we made a chord out of 1, 2, 3, 4, 5, 6, 7, the seventh note, that's called our seventh chord, right? That's a separate pattern that uses 4 notes to make a chord. It's still a C major chord, but it's a C major seventh, because the C major is this, the C major seventh adds the seventh note. It's still the first degree of our C major scale, and it can be used in most places where you would use a C major triad. It's just that when you use it, because it's got the extra colour of that final note there, it makes the harmony a little bit richer. Similarly, there's a seventh for the second degree and for the third degree, etc., etc. Sometimes we want these chords that have this extra bit of colour. The same is true for our minor. Here's our C minor scale. We can add a minor seventh here, which is a great sound. I overuse this myself. I like that minor seventh a lot. And again, it's exactly the same principle. You take the notes that fit the scale you've got according to whether you're in a major or minor and what your tonic is, what your key you're in, and in this case you count the 1, 3, 5, 7 note within that. And I've added this to the code as well. So in just the same way you type these numbers, I made a slightly strange decision. You'll see why I decided to represent it this way. The seventh of the 1 is with the number 71, the seventh of the 2 is 72, etc., etc. So these are now our seventh chords within, let's say, C major, just so that it's easy to understand. We can see it. And of course you can see the same for, say, C minor. So always confusing if I do that. I should stop this. It leaves some of the notes on. Let's do it again. So that's it. That's what this chord sequence does for us. So we can now use it to explore. We can now use it to explore chord sequences. We can start with a 1 6 4 5, which obviously is very popular, and hear how that sounds. But how would it sound with sevenths? Versions of those chords. Or with, say, a mixture. We'll leave the tonic, so we'll leave the dominant and the sixth. Now, typically, we think of the tonic as being the kind of home. That's where a lot of harmonic theory is about cadences. In other words, the kind of sequence that's a trajectory that's bringing you somewhere. And you normally think of it in terms of moving from dissonance or something that sounds a little bit uncomfortable by itself towards, what's the opposite of dissonance? Towards your tonic, or towards a place that feels more restful. So the places that feel restful are typically the 1. The 5, the dominant as it's called, is a sound that really wants to get back to the 1. If we just put in a 1 5 here, that's also a pretty common thing, particularly if you stretched it out a bit. You could imagine a lot of music actually just kind of goes backwards and forwards between those two chords. So 5s by themselves kind of feel unresolved. They feel like they want to go somewhere else, or at least they do once we're thinking of them in the context where we've heard the 1 and we know that it is. We've heard the 1 already at the beginning, so we kind of feel it is C major, and so we want to go back to C major. So when we hear the 5, that feels unstable. It wants to take us back. The 4 is the subdominant, I believe it's called technically. That can also take us back to the 1. I believe the 4 to the 1 is... Now this is where the arbitrary naming of things. I think that's what's called the Plagal Cadence. I will delete that if it's not, but the Plagal Cadence is... I'm just going to Google it. Plagal Cadence. It's a resolution. It's a weaker resolution going for the dominant. Okay, the main cadence is from the 5 to the 1. Yeah, Plagal Cadence is from the 4 to the 1. But, you can see there's so much more complexity here, which we have not even started getting into. So I'm not going to go there, but yeah. So the 4 to the 1 is standard. Things like the 3 and the 2 are places to visit on the way. Let's try a 3 to a 4 and then to a 5. How does this sound? Okay, I mean that's fairly simple. Let's switch them around a bit. Now it's changed. 6, 2, 5. Now, going from the 5 to the 1 is always kind of comfortable. Let's try this way. 2, 4, 5, 1, 3, 6, 2, 4, 5. This is how you compose music, right? You create these chord sequences, and we now have a way of doing, without us, being able to play them ourselves, we now have a way of very quickly experimenting with them and seeing what sounds good for us. I mean, let's say I like that, okay, now I can go back to FL Studio and I can just record it. Except, let's put ourselves in the right. It doesn't really matter if you record at the wrong time because you can just change it afterwards, but for convenience. Oh yeah, let's go in here. 1, 2, 6, 7, 2, 7 to 4, 5, 1, 3. I think we missed that time round. So you can hear how that has already given us plenty of material to work with. We'll just get into that. And we can obviously do things now like change the voice. If we want to move this to a completely different instrument, let's put in a citrus or something. Sometimes we just add so much. I'm not building this into a whole beat at this point, but you can see the principle. We generated those chords and we now have so tempting, isn't it? you get some chords and it's just like, wow, let's make something with this. But yeah, I'm going off topic. So I found something here that I like. This is kind of minor chord sequence here. This works pretty well for me. Actually, yeah, I hear this and I'm so inspired. I'm like, oh. have to remember to stop it. So that's it. That is what we can get out of this. Simply now just by playing around with these numbers. I mean, I hope some of the music theory behind this makes sense, but obviously the convenient thing here is that you don't actually need to learn to do the calculations in your head to figure out what the notes are for these various combinations of chords, which makes life a lot easier. So let's now look at this chord seek function. How does it actually work? We define it up here, standard way of defining functions in Sonic Pi. Sonic Pi is almost Ruby. It's kind of Ruby, but it's some error and kind of reserves the right for it to be slightly different as well. So this is how we define our functions. And, we take the three arguments, the tonic, the mode. So the mode is the major or minor, the array of degrees. The tonic is a C3. I define these four arrays up here. Now, Sonic Pi has standard names for all the different chords and combinations of chords. So it uses this capital M as a shorthand to tell it has a function for generating individual chords. And so if I want to generate a major triad in C major, I type chord C3 and then I say M, for example. So that's telling it, make me a chord starting on C3 that's a major triad. So that's half the work for us. What it doesn't do, though, is it doesn't help us with the appropriate calculations for, okay, here we are in the key of C, but what's our 4th degree major chord? Well, it does help us with that a little bit. We have to look some of this stuff up, and these arrays here contain the data that we need. And the data, most of the chords are either major or minor. So here in the major key triads, you'll see that the 1st degree, so this, so if we remember, the 1st degree in C major, the 1st degree chord is the C major triad, is like that. But the 2nd degree chord is a D minor triad. Okay, because if you remember, we're counting up 1, 2, 3, and then 1, 2, 3, 4. So that's the piece of information which we have to capture here. And that's what we're doing in these arrays. Like the major key triads, I'm saying the 1st degree is a major chord. The small lowercase m is a minor chord. That's the shorthand for it. When we get up to, so that's 1st, 2nd, 3rd, 4th, 5th, 6th degree. Those are obvious. When we come up to our 7th degree, this one here, that is a slightly weird chord because it's spanning both of these points where we have no black note between the notes. And so the calculation for it, if you look at it, we actually go up 1, 2, 1, 2, 3. Sorry. The first step is just up 3, but then the second step is also just up 3. So instead of the whole thing being a perfect fifth from here to here, it's actually one less than a perfect fifth. It's just, instead of up 7, it's only up 6, which is called the tritone. So this is a rather dissonant sounding interval, and it's what makes the 7th in the major scale sound slightly weird. And because of that, we can't say to Sonic Pi, okay, give me a standard major triad or a standard minor triad to make this chord, because it's not a standard major triad, it's not a standard minor triad. What it is a diminished. So the Sonic Pi name for that is colon dim. So that's why when it comes to the 7th degree here in our major key triads, we use a diminished. When you come to look at the minor key triads, actually it's the same things, it's just they're in a different order. If you remember, the minor key that has the same all white notes that C major has is the A minor. So here we're actually using the same chords, they're just kind of happening in a different order. So the first degree is a minor. The second degree gets the diminished in this case, this one here, because again we're starting on the B. If you think starting in A minor has those notes, but it's precisely the second degree, the B, that spans this area where there are these two regions without the black notes. So that gets the diminished for its second, then it gets a major, minor, minor, major, major. When it comes to the sevenths, then the sonic pi way of representing those is capital M7 is the minor, the major 7, small m, lowercase m7 is the minor 7. There are two other specific ones. There's the dominant seventh, which is like this. So an ordinary major seventh is like this. Up 4, up 3, up 4 again. Okay, the minor seventh is like this. Up 3, up 4, up 3 again. Up 4, 3, 4. Major seventh. Up 3, 4, 3. Minor seventh. This, which is a bit of one and a bit of the other. Up 4, up 3, up 3, is what we call our dominant seventh. And again, it's got that slightly dissonant, but not entirely dissonant. It's just, it's a kind of rich sound. I'm sure when you listen to it, you can now think of the kinds of music that will use that sort of sound. But it is a combination we're going to need at certain points on. Well, it's called the dominant seventh because it's the kind of seventh we need on the dominant. So the dominant, again, if you think of it, is the G. It's here, right? Starting on the, if we want to stick to the white notes, that seventh there has to have, so the first three are just a standard major, but that seventh has to be there, not there. You know, that's your standard major seventh, but that's not in the scale because it's got the black note. So we've got to. So that's why the dominant seventh has to be that specific kind of chord. And then there's a half diminished chord on the B again, which is giving us. Again, the calculation is to make sure this is all on. It's funny. No, it won't let me play 4 notes at the same time. So again, that's a slightly different shape, and that is called the half diminished. For our major key seventh, it's that order in that array, and for our minor key sevenths, again, it's the same combination, it's the same collection of chords, but again, in a different order. So that's where the real music knowledge is going on, is being captured in this chord sequence. You know, that's the thing that people who are real musicians are going to spend a lot of time having to get into their heads and be able to kind of do in real time. And that's the thing that the program is letting us cheat by giving us that information conveniently. After that, everything is more or less as you might expect. We create an array to put all our chords in. We've received this array of degree numbers here, and we're just going to loop through that. We use a Ruby case statement on that, and the convenient thing about Ruby is you've got the case statement has like case, what's the value of the degree? Well, when the value is in this range 1 to 7, that's what this notation 1.7 means, and it's inclusive, then we do this branch of the case statement. When it's between 71 to 77, we do this branch of the thing. Now you see why I chose this slightly strange notation of making them 70 something. We could have kind of chosen a notion of 67 and 57, But then it would have been more laborious to pick up in a case statement, so I just decided to turn it around and say, okay, because it's easy to define a range 71 to 77 more than give me the numbers 37, 47, 57, etc., etc. So yes, it's convenient for us. I hope it's fairly intuitive, but it's also that way because it makes the programming much easier. But anyway, go back to this first case. When the numbers are the simple ones, so we just want the triad out, the 1 to 7 triads, then Sonic Pi has got this function called degree that does the real difficult work for us of saying we're in the key of C, but for the 4th degree in C major, what's the note that our chord starts on? Okay, so we've got C, we know we're in C major, we know we want the 4th degree, we want this note. What is this note? Okay, it's an F, but how do we calculate that? Well, to be honest, Sonic Pi calculates that for us. So with this function called degree, which you give the degree that the 4, in this case the tonic, which is the C, and you give it the mode major, and in return it gives you what I'm calling the root, right? The root of the chord we want to generate for the 4th degree. So this chord here. So that's what this line does. We use Sonic Pi's own degree function with the data that it has to have, the value of the degree, the tonic, the mode, gives us the beginning. Now we just need to build an appropriate triad starting here. And we just need to know, remember, do we need to build a major triad or do we want to build a minor triad? Well, we can find that out because we've got these arrays. We know in the case, well, now we're going to test here. This is an expression to test whether we're in a major or minor key. It's a conditional expression. In other words, we put the condition here, then we have a question mark, and then if that condition is true, the result of this is this. If it's false, the result of this is this. So effectively we're taking lookup is, if it's a major key, lookup variable is going to contain the major key triads, this array. If on the other hand we're in a minor key, then we'll just assign the minor key triads array to the lookup a variable called lookup. Similarly, if we're in our sevenths, if we've asked for a 7th, remember that the degree number contains this 70 we don't really want, so we just take that away from it to get it back to the same 1 to 7 that we do before. We do the same root lookup here, degree tonic mode, and then the degree calculation is the same as there. And now our lookup is, instead of, if it's being based on the major minor triads, it's going to use these two arrays. So at the end of this case statement, we've figured out, we've got ourselves the appropriate array of these 4 to do our looking up of which chord we actually want to build, and we've assigned to the variable root the note we're actually starting on. So if we started with C major and we asked for the 4th degree, root is now going to contain this F, and if it's an ordinary C major triad, the lookup array is going to contain this data here. So now all we do is we say, what's the actual chord we want? We use the chord function of Sonic Pi's chord function, which again just takes 2 arguments. The first argument is the root we're building on, so now it's this F, and lookup degree -1. Okay, so the arrays are indexed 0. These numbers are given 1 to 7 because that's the convention that we use in musical notation or in music, talking about music. Arrays in Ruby are indexed from 0, so we just have to take away 1 to get the array index that we need. So that's what we do. The chord, now we build the chord using Sonic Pi's own chord building function, and now we just append to this collection of things this short array that contains our tonic, our mode, and the chord. Remember, the reason we're putting the tonic, we could have just put chords in an array, but it's convenient for us to have the tonic and the mode as well when we come out here. So we just unpack it all at this point. So that's it. Again, not a very complicated idea. Once you understand the complexity of these calculations, musicians have to learn it. Actually working this out from scratch is a little bit more fiddly. Sonic Pi gives you the degree function and the chord function that do some of the work for you, but to do the rest of the work, to incorporate the rest of the kind of music theory, we just made ourselves these tables or these arrays with the lookup to look up the appropriate data, and then bundle the whole thing in chord sequence, and now we've got a convenient interface or API that will let us just choose chords for our try that. In fact, what would be, we could double that and just make that my 5. So we just changed the 5 to a 1 there. Now we've got this. So we've already got our chords. Why, just as a reminder, why would we find it useful to have this tonic and this mode again? Well, we can of course maybe add some random melodic elements on top of this. So we could say, for example, what we'll do is we'll create a scale here, and a scale is the same as a chord. It will take a tonic and a mode, and then we'll just choose. So that gives us, in this case, for example, that's going to give us all the notes in this scale. We will choose a random one from it, and we will add 24 to push it up a couple of octaves. And we will just, MIDI is a shorthand for sending a MIDI note on and a MIDI note off, although it's got a standard time. I can't remember what the time is. We'll send it at 50 velocity, and as before we'll only send it to the loop B port. Then we can do the same thing again here after sleeping for another 0.4. So we've got 1, 0.4, 0.4, and then we only still do the, let's hear how that sounds. I think that's it. I mean, that's what we'll talk about today. That is pretty, I think it's pretty powerful. I think if you want to start playing with chords and start understanding chords, and you are, like me, too lazy to actually take piano classes or something, then this is kind of a nice intermediate between just using loop packs that come from somebody else has composed the chords for you, and doing all the music theory yourself. We've put the music theory into this function and done the calculations function. Now we can just play around with these chords. And of course, and there are many more kinds of chords, more sophisticated harmonic chromatic type chords. At some point, the more sophisticated musicians are not just following the rule that these are the chords you have to use at this degree in this key. They're going to start using extra chords from outside the key. They're going to do secondary dominants and things which kind of come from a related key. They're going to do modal interchange and put a chord that comes from the minor version of the key in the major, if they're in the major, or a minor, or a Lydian version from somewhere else. All of these are extras that if we wanted to, and maybe I will in a future video, we can add now to this function to add some more complexity for it, but try to keep the usage of the function, try and keep this simple way of actually playing with these things. But I'm going to leave that for another video. So that's it. Synsmedia, I'm out. This is the end of this video. It's going to take a ton of editing to get it into usable, listenable shape. But yeah, I'm glad to be back in Sonic Pi. I hope you're glad to see Sonic Pi back, because in fact we're going to do more Sonic Pi stuff. We're going to get back to actual real life coding, or at least real music in Sonic Pi itself, and some other programming tricks we can do with it. So thanks for watching. Synsmedia, I'm out.